In this video, let's understand how to find the HCF of 12 and 24. But to do so, we'll first have to know what HCF or highest common factor is. Highest common factor of two numbers is the greatest number that divides both the numbers completely without leaving any remainder. But now the question is, how do we find HCF? Well, we can break down the process into three basic steps. In the first step, we have to find the prime factors of the given numbers individually. In this case, we would have to find the factors of both 24 and 12. The second step is to find the common factors amongst them. And then finally, we have to multiply these common factors to get the highest common factor. Doesn't all this sound very simple? So let's get started with our process. We have to find the prime factors using the prime factorization method. And by now I am sure you know how to do prime factorization by making factor tree. So factor tree of 24 is like this and the factor tree of 12 is like this. Is there any other method of doing prime factorization? Yes, there is. It is called ladder method. Now let's find out the prime factors of 24 using the ladder method. So in this method, we first have to draw a ladder like this. Now we write the number which we have to factorize here. In this case, it would be 24. We have to continue to divide this number with a prime number till the time we get 1. Next, here we write the smallest prime number which can divide the given number. And then finally, here we write the quotient which we get after dividing. Now let's start our process then. We start with the smallest prime number, that is 2. And we have to check whether it can divide 24 or not. So can 2 divide 24? Yes, because 24 has 4 as the last digit. Hence it is divisible by 2. So 2 comes here and the quotient, which is 12, comes here. Now we have to divide 12. Let's try it with 2 as it's the smallest prime number. We know 12 is divisible by 2 because 12 ends with 2. Hence it is divisible by it. So 2 comes here and the quotient that we'll get after dividing is 6, which will come here. Now similarly, we'll divide 6 by the smallest prime number, which is 2. 2 can divide 6. So we'll write 2 here and the quotient, which is 3, will come here. Now we have to divide 3. We know that 3 is a prime number and can only be divided by 3 or 1. But here we have to divide the smallest prime number. So we'll divide it by 3, as 2 cannot divide 3, right? So, and if we do, then our quotient will be 1, which we'll write here. I hope you understood up till now. Similarly, after this, we'll try and find the prime factors of 12. So we'll again draw a ladder like this. But here, we are not going to do the whole factorization. As you see from the second step of factorization, we have basically done the factorization of 12. So we're just going to copy the steps here. As you see, the steps are going to be same in both the cases. Now, my next question to you all is, did you see whether we did prime factorization by making factor tree or by the ladder method? The prime factors that we got were the same. Keeping that in mind, now let's move on to our next step, which is to find the common factors. To do that, first I'll remove this factor tree. So to find the common factors, I'll first list down the factors. So 24 equals 2 into 2 into 2 into 3. Similarly, 12 equals 2 into 2 into 3. Now let's circle the common factors now. So 2 is common in both, so let me circle them. If you see, I have circled number 2 twice as it's repeated as a factor twice for both the numbers. If you see, I have circled 3 also, which is a common factor for both the numbers. Now that we have found the common factors, it's time to find the HCF by multiplying the common factors, which is 2 into 2 into 3, which equals 12. If you carefully see that for the first set of 2 which were common, I have written 2 here Then for the next set of common factor 2, I've written the 2 here. And for the 3 that was common, I've written it here. Multiplying gives us 12. This means that the highest common factor of 24 and 12 is 12. Wasn't this simple? But still, if you found anything that was difficult, I would encourage you all to watch the video again.